Have you ever wondered how a basketball player makes that perfect shot? Or what about a rocket? How does it just defy gravity and soar into the sky? Well, believe it or not, it all comes down to a set of invisible rules. Rules that govern literally everything that moves. And to understand them, we've got to start with the simple question.
Right, a basketball, a car slamming on its brakes, a massive rocket blasting off. What's the connection? The answer is hiding in three fundamental laws. Rules discovered more than 300 years ago that to this day explain the very nature of force and motion.
So, here's our big question for this explainer. How do forces actually make things move or stop moving? To get to the bottom of that, we first have to tackle a really common idea that honestly most of us get wrong.
Okay, really think about this for a second. If you roll a ball across the floor, it eventually stops, right? If you're pushing a heavy box, the second you stop pushing, it stops moving. So, it seems like an object needs a constant force just to stay in motion. What do you think? True or false?
The answer is a big, resounding false. And I know that feels totally wrong, but this insight is one of the most brilliant moments in all of physics. An object in motion absolutely does not need a force to keep it moving. So, why does everything on Earth eventually grind to a halt? And that brings us to Newton's first law. See, the reason our intuition gets this wrong is because we're forgetting about all the invisible forces at play. That ball you rolled, it was slowed down and stopped by friction. The box, same thing. Here on Earth, there's always something pushing back. Friction, air resistance, you name it. But if you were out in the vacuum of space and you pushed an object, it would just keep going and going, literally forever.
Okay, so that's the theory. But theory's one thing, seeing it is another. So let's put these laws into action. We're going to do a super simple, hands-on experiment that you can easily build at home to make these invisible forces, well, visible.
It could not be easier. You just thread a long piece of string through a regular drinking straw, then you stretch that string nice and tight across a room. Then blow up a balloon, but don't tie it off, and tape it right onto the straw. Once you're all set, just let go and watch what happens.
So as you watch that balloon rocket zip across the string, start thinking like a physicist. Ask yourself a few questions. What was the force that actually pushed it forward? And what do you think would happen if you used a bigger balloon? Would it go faster? And what if you taped a little coin to it to give it more mass? See, this is exactly how science works. You observe, you ask questions, and you make predictions.
All right, so what did we just see? That little zipping balloon, that was a perfect and really simple demonstration of another one of Newton's incredibly powerful laws. So let's break down the science behind what made our little homemade rocket fly.
What you saw was Newton's third law in action. For every action, there was an equal and opposite reaction. Think about it. The action was all that air rushing backwards out of the balloon. The reaction, the equal and opposite part, was the balloon getting pushed forwards along the string. And guess what? This is exactly how real jet engines and rockets work, just on a slightly bigger scale.
Okay, let's put it all together. The first law, that's inertia. Basically, things are lazy. They want to keep doing whatever it is they're already doing unless a force messes with them. The third law is what we just saw, action-reaction. For every push, there's a push back. And that brings us to the second law, which kind of ties it all together. It's that famous equation, F equals ma. Force equals mass times acceleration. This answers our other questions. If you use a bigger balloon, you get more force, so it accelerates faster. But if you add weight, more mass, you need an even bigger push to get it going at the same speed. It's that simple. 3 rules to explain, well, everything that moves.
And believe me, these aren't just ideas for a physics class. We use this stuff every single day. The reason your seatbelt locks up when a car stops suddenly? That's engineers using the law of inertia to save your life. The thrill of a roller coaster, the power of a jet engine, the launch of a rocket into space. It's all built on these 3 fundamental laws.
So who was the absolute genius who put all this together? To really appreciate these laws, it helps to know a little bit about the man who figured them all out, the one and only Sir Isaac Newton. So get this, there was a major plague outbreak and Newton's university had to shut down. So he just went home to his family's farm to wait it out. And during that period of isolation, he had what's now called his Year of Wonders. In that 1 year, he laid the groundwork for his 3 laws of motion, his theory of gravity, and he even invented calculus. His work didn't just explain motion, it gave humanity the mathematical tools to predict it. It changed everything.
So what are the big things to walk away with? First, and this is the big one, Remember that motion doesn't require a constant force. Second, forces always come in pairs. For every action, there's a reaction. And third, mass, force, and acceleration are all beautifully connected. These simple, elegant laws are universal. They work for a little balloon rocket in your living room just as well as they work for planets orbiting a star.
Now that you know Newton's laws, you can start to see the world in a totally new way. You can almost see the invisible web of pushes and pulls that shape everything happening around us. So, the next time you throw a ball, or ride in a car, or just watch a leaf fall from a tree, think about it. What forces are at play, and what do they tell you about the beautiful, predictable rules that run our universe?